before. Okay. Here we give the IP addresses with a 32 bit. So 32 bit is divided into 4 parts. So how many in one? 8 bits. So in one part we use 8 bits to locate. So this is for IPv6. So we have two facilities right now, because from 2012 that has been increased, right? So IPv4 we are using as well as IPv6 we are using. So let's see my system has which particular address, because this particular address what I have made is obtain IP address automatically. It will obtain automatically. So there are called dynamic host control protocol, DHCP, host control protocol. So DHCP what it will do is dynamically it will allocate the addresses, so you doesn't have to write those IP addresses. Getting it? So previously when I was there in NIT, so over there we are using, in the lab we are using static IP addresses. Slowly it has been become dynamic host control protocol. DHCP protocol has been come up. So it is depend upon the server, what server you are using, what technology you are using. Let's see in this particular system what is the IP address. So you see the IP address, this IPv4 has been used. So my address is 172.17.1.254. It is a reserved type of addresses which is used for the local data. And what is the IP address which is a unique IP address, you know? Which is the unique IP address? Would anyone tell me? That is for the DSC server. Sorry, this DNS server. What we have an DHCP server. So we have two type of server. This is dynamic host control protocol server, which is giving me the addresses, and this is DNS server. This is domain name servers. So by this domain names here, we are connected to the internet. We all are connected with the internet. So outside this institute, if anybody want to see me, it will see me with this particular address, 192.16.1.60. This is again an IPv4 type of addresses. So nowadays I can use IPv6 type of addresses. So in the IPv6 type of addresses, how many bits? 128 bit. So have you seen this? So here how many bits we can use it, right, for the addresses. So it is very huge. You can see this. We can put the data here and it is very huge. So to the power of 128 addresses can address to every atom of this atmosphere. These much of addresses are there we have. So I don't think so this 128 or the IP version 6 is going to exhaust. It is never going to exhaust. So this is about your IP address. And why I am telling you IP address? Because we have the technology called 6LoWPAN, which is using IPv6. So it should communicate over IPv6. That's why I told you all these things. Over low power wireless personal area network has been adopted by many companies to implement energy efficient data transmission for IoT network. If they are making, if any company, any institute, any firm, if they are making IoT network, so they are using this particular protocol. 6LoWPAN uses reduced transmission time, typically short time pulses, and thus saves energy. So different technology has different pros and cons, right? Some are using more data transmission. If more data transmission for sending one data, So definitely it is using more energy. So how efficiently we are sending the data? If we are sending the data efficiently, means with the reduced size, definitely my energy cost will be reduced. Yes or no? If I take an example, in this particular class, if I communicate with you and I tell you anything in one sentence, so the people who are sitting in the front bench can get those sentences very easily. Means no words will be what? Every words are clear for them. If I'll go to the back benches, my words are not clear. Yes or no? If I'll reduce my transmission energy and I'll talk in a very slow form, so what will happen? Only some of the front benches will understand and then back benches could not understand. Yes or no? So for that what I have to do? I have to again tell the same sentences, so that whatever words that was not understood by the backbenchers can be understood. The same way it was happening to the MacLeads. If I am sending any data and the receiver cannot receive whole data, I told you na, the data has been divided into some packets. So let's say I am sending 10 packets and you haven't received 10 packets, you have received 8 packets. So again I have to send those 2 packets. Are you getting it what I am saying? So again sending those 2 packets, it is a waste of energy. Yes or no? Yes or no? So why don't we make our protocol in such a way, whatever signal I'll send to one node to another node, it should receive properly. If it is receiving properly, then the energy of that particular sender will get reduced as well as the receiver. Getting it? So the technology has been come up, refine has been done, many research has been taken up, so that very less number of bits has to be sent, very less number of data has to be sent for one data, the header and trailer size get reduced. So these are the many things that has been come up, and many technology is coming nowadays. Are you getting it? Are you getting it what I am saying? So we are using all these devices, all these protocols to communicate with IoT devices. So we'll see one by one all those things. We'll see many other protocols which are using in different layers. This is about MAC layer. Then we have network layer. So we'll see what are the different protocols we use in network layer and transport layer, as well as in application layer. Because when you talk about network, all those 5 layers should be involved. But for one-to-one communication, if we are involving only 2 layers, that is okay. But all those 5 layers is the part of any computing device. Whether you are using or you are not using, it is up to you, or up to the technology what we are using. Are you getting it what I am saying? As well as for two devices, the language should be same. Means if I want to communicate with you, my language and your language should be same. Then only I can communicate. Or if I am I am talking in English and you cannot understand English, so what will happen? There is a miscommunication. That is called miscommunication. Yes or no? My communication will not reach to you. Whatever I am saying, you cannot understand. If you are saying to me something in Odia, I cannot understand fully. So both the devices should follow same protocol, same rule, same language. Yes or no? So in the next classes or subsequent classes, we'll see different heterogeneous devices, how they are communicating. Homogeneous devices means they are using same protocol, they can communicate very easily. But in a heterogeneous scenario, where one device is there which is using low pan, another devices are using Zigbee, or another devices are using Bluetooth, how they can communicate? They cannot communicate. So So there should be a central point which is used all those things, and that is called gateway. That is called gateway. So the next device which has come up is called gateway, because gateway will make the interface between IoT devices and cloud. And cloud is means internet. In the internet, whatever machines we are using virtually, whatever technology we are using virtually, that is called cloud. So the cloud cannot understand ZigBee, cannot understand LoWPAN. It will understand only TCP/IP protocol. So for that, you should have a gateway. You should have an interface which will communicate with you as well as with the cloud. Because ultimately we are talking about Internet of Things. Yes or no? So we have to send our data to the internet, and then the processing and all these things will happen. So what is the use of gateway? First of all, gateway is an interface between your IoT device and the cloud. Okay. So here is a representation of a gateway in the form of Raspberry Pi. Raspberry Pi is onboard chip. Why it is called onboard chip? Because in one board we have all the computing things. It has USB cable, it has sending for, there is a Bluetooth, there is a Wi-Fi, there is a RF, everything is there in one board. There is a processing power, there is a memory, everything is there. So it is a mini computer. Right, that's why we say it is a onboard chip. It is also called Raspberry Pi. It will work as a gateway if we are using any IoT devices like Arduino. We have sensors are connected with it. We have some devices are connected with it. So this is the gateway. What is it? First work is the interface. What is the second work? Second work is pre-processing. If any IoT devices is generating the data and sending, it want to send to the internet. So before that, there is a pre-processing that is happening in the gateway. So gateway can do pre-processing so that it doesn't have to send whole data. Let's say some of the data are relative, some of the data are not relative. As well as whatever collecting data I am receiving is the same. Let's say we have the temperature sensor. Okay. I have 10 rooms. In all room we have the temperature sensor which is collectively taking the data. Yes or no? Let's say I have 10 rooms and all 8 rooms are giving me same temperature. Can I send same temperature all the time? So I'll do the aggregation, I'll make an average and I'll send it to the, so my building, whole building have this temperature, in that way it will send it. So instead of sending 10 data, it will send only 1 data. Getting it? So this type of pre-processing will be done in the gateway. IoT gateway manage the bidirectional data traffic between different network and protocols. So different network and the what protocol we are using. So it is what I told you. We have different type of protocols. So they cannot communicate with each other. So we need an intermediate type of devices, which is gateway. Another function of gateway is to translate different network protocol and make sure interoperability of connected device and sensor should be there. Interoperability should be there. They can communicate with each other very easily. So there is a gateway which knows the protocol of that side and this side also. Gateway can be configured to perform pre-processing of collected data from thousands of sensors locally before transmitting to the next stage. What I told you is it will do pre-processing before giving to the next level. In some scenario, it would be necessary due to compatibility of TCP/IP protocol. What I told you is, so in the Mac layer we use different protocols. What I told you just now, and in the internet we use TCP/IP protocol. So it is a different type of protocols. Because we are talking about two different type of network. One is IoT network, another is internet. So if you want to communicate the IoT network to the internet, we should have a common platform, right? And that common platform is nothing but gateway. IoT gateway offers certain level of security for the network and transmitted data with higher order encryption techniques. It acts as a middle layer between device and cloud to protect the system from malicious attack and unauthorized access. Sometimes the gateway has this encryption decryption power by which whatever data has to send, the sensor data has to send to the cloud, it will encrypt it and send, and whatever data has been come up from the internet, it will decrypt it and send to the sensors, because these sensors and these nodes having very less power, very less energy, very less processing power. So what they will do is they cannot do all those complex encryption decryption algorithms. So the gateway will do behalf of them. Getting it? That is a work of gateway. What is this? Interface. It will become an interface between two different network. Second, it will do pre-processing. Third, it will provide the security. So these are the three major work of a gateway.